Hi, this presentation will examine confidence intervals for population proportions. So here we're going to start with the point estimate for a proportion, the probability of success in a single trial of a binomial experiment is p, as you'll recall, and this is the population proportion. You'll notice p does not have this hat on it. If it does have the hat, we're talking about the sample. So the sample proportion is our best point estimate for the population proportion, and the sample proportion is the number of successes over the number of trials, n, which is our sample size. And q, as we see down here, is the complement of p, because it's 1 minus p, and we know that p plus q have to equal 1 in a binomial experiment. So for example, if we have a survey of 1,250 adults and 450 said their favorite sport to watch is baseball, we want to find a point estimate for the population proportion of adults who say their favorite sport is to watch baseball. So the sample proportion is going to be x, which is baseball, over n, which is 1,250 adults, which gives us 0.36. So the point estimate for the population proportion comes from our sample proportion of 0.36. So after we find our point estimate, our next step is to build a confidence interval where we have our point estimate minus error. We have our point estimate, our population proportion is in the middle somewhere between minus e and plus e from the sample proportion. The probability that the confidence interval contains the population proportion is c. And this formula, E equals Z times the square root of PQ over N. And those are the sample proportion and its complement. So to build a 90% confidence interval, we find the Z point for that. We have 1,250 adults, 450 say they like baseball, the sample point estimate 0.36. And using that, we can use 1.645 for our confidence, for our z-score, to build our confidence interval at the 90% level, and that will give us 0.022, roughly. So our left endpoint is going to be 0.36 minus 0.022, and the right endpoint plus 0.022. So with 90% confidence, we can say that the proportion of all U.S. adults who say baseball is their favorite sport to watch is between 33.8 and 38.2. So to summarize the steps in finding a confidence interval for a population proportion, we go through these steps. One is identify the sample size and the number of successes, x. From that we can get the point estimate by dividing x over n, and that will give us our sample point proportion. Verify the distribution can be approximated by the normal distribution, and that requires the sample size times p to be greater than or equal to 5, and the sample size times q hat to be greater than or equal to 5. From there we go to finding the critical value based on our level of confidence. We then find the margin of error, E, to be that z-score times the square root of the product of p hat and q hat divided by n, our sample. Finally, we can use that to create our left and right endpoints and to have this interval of p hat minus e or plus e, and somewhere in the middle of that is our population proportion. And this is the formula that we can use to determine the sample size needed to achieve a confidence level with a margin of error E. So we would just rearrange the formula we saw previously so that n is now equal to the product of p hat and q hat times the z-score divided by error squared. And that formula does assume we have estimates for p hat and q hat. If we don't, then we just substitute 0.5. So for example, if we want to find out at a 95% confidence level and within 2% of the true population proportion, the proportion of adults who say that baseball is their favorite sport to watch, we can come over here and plug in these numbers. We did have values for P and Q, so 0.36 was P hat and Q hat was the complement of that. And then we have our z-score and our E, which is plus or minus 2% as given by the example. So we would need to have a sample size of 2,213 rounding up. And that would give us 95% confidence that our interval contained the true population proportion.